I think everybody's back, right? Anyone at home still not here from this decay already too? Okay, so I will start now. Okay, just before we break up, we have seen a lot of examples how to sketch the normal curve, right? Check, look at the z-score, whether it's the positive or negative side. Then how we use the normal table, right? To give us the probability which is shaded outside. So anything you want to find the other way, you must take 1 minus the one that is given in the table. So you must see the inequality side, is it more than or less than? Okay, and then the most important thing is the characteristics is both sides, whether it's negative or positive, there must be symmetry, which is the shaded outside one now. Okay, so and then those with the probability z between two positive value or two negative value, you must know which one minus the bigger one minus the smaller probability. Yeah. So these are the some of the questions that you will find it when you do your class here. So make sure you all practice for. Okay. Now for the second part, which I mentioned just now, so far you are given the z value. You find the probability, right, from the table. Now this type of questions is we call it the other way around. They give you the percentage, which is what probability. You have to find back the score. Okay, now I just write down the summary here. Previously, before we have a break, we are given the z-score. We find the probability from the table. Now you're given the probability. You have to find back your z-score. This is the challenge. A lot of people, they only know one way. They calculate the z-score, they use the table, they can find the probability. But when the question gives the probability, they find back the z-score, they cannot do it. You know why? Because they don't know whether the z-score is positive or negative. I told you, right? Positive right hand side, negative right hand side, but they still don't know why. So the challenge is there. Actually, there is a way to, like, you must know whether it's positive or negative. You must look at what? Probability, if any half, no issue. If more than half, then you must shift your positive to negative or negative to positive. Okay, let's look at one example here. Determine the lifetime of the components such that only 10% of the components will fail up. So this one refer to the example. Remember the mean is what? 1000, right? The standard deviation is 200 up. 2000 up. Okay, refer back to the same example. So this is the lifetime component. Okay, now they give us 10%. 10% refer to what? Probability. That's why I mean I'm given the probability. So this is how you write. Let K, now I use K or any symbol, because the question want you to find the lifetime. So previously we used the X as the lifetime. Now we cannot use the X. We use what? K or P or anything as the lifetime. So this is how you write. Fail means what? Another problem, if people they don't know how to answer this, is they don't know whether you put more than or less than. You see this word fail means what? More than or less than? Before the time. Before the time fail means usually must put less than, right? Before the lifetime limit, the probability to get is only 10%. So this is how you write. This one will give you 1 to 2 marks. First step wrong, no need to do already. Out of this maybe 4 or 5 marks, we see that most people first step wrong is you must put less than, because this one fail fail means less than the required lifetime. So less than what? K. The probability is 0.1, 10%. So you know very clear now, right? Given the probability, you have to find the z score. Remember, this is your x have to change to z. Still have to change to standard law. So this k must minus what? 2000 divided by 200 law. Same method, right? Because x change to z. K the price up and minus the mean and divide by standard deviation equal to 0.1. Now, two issues already. First, they don't know how to write. Second, they don't know where's your z. This is your z, right? They don't know whether positive or negative. Another problem. Simply put, positive also can, negative also can. Do you think same answer? Definitely not same. So I ask you, you don't see the answer everywhere. You have to think. Yeah. If you understand the concept, you can answer me. This one probability is only 0.1. Remember I told you half is 0.5, right? Half 0.5. Now, 0.1 means very small, right? Very big or very small? Very small, less than half. If you talk about 0.7, 0.8, then it's more than half. So I tell people, if you're not sure, then you look at this 0.1, it's very small, less than half. And then if you write correctly less than, so if you put here, let's say you tembak lah, use the word tembak, you guess lah, you don't know right? You just guess, let's say you guess positive first lah. So you tembak first, let's say this is the k value, or the z value lah. Then you ask yourself, if you understand the concept already, okay, fine, you tembak here first. Every time before you answer, you tembak. Okay, less than, what do you understand? You shape which one? Smaller, right? So you right or left? Yeah, less than this value. You think this one is equal to 0.1? Possible or not? No, this one is already half the low. Plus this one. You think left, right, up, down also cannot be 0.1, right? Impossible. So you think positive is correct. This time you tembak wrong already, cannot be positive. Now, let's say you change it to negative. So you do tutorial question, you do like this, then you change to negative. Think logically. Negative is left hand side, right? Less than this one, right? That's smaller. Do you think this one possible becomes 0.1? Possible, right? Small area, less than half. So that's why your z must have a negative. Provided your inequalities here you write correctly here. If those of you write more than one, also gone. So from the table, refer to the normal table. So we know this is a z square equal to, do you know how we get this from? Okay, 0.1, everyone. I'll show you how to get this. Negative is there, can you see negative is there? Okay, 1.2816, can you scroll down? There is another table here. 0.1, do you get this table in your notes? Yes, right? Anyone? Can you see this in your notes? Okay, so you see this one? This is the second table, first table. I'm not sure how many of you have seen this second table before, very short one. Now, this is your alpha. This is your mu alpha, right? This mu alpha is your probability. This is your z score. This is your z score. They use a mu alpha. They use a mu alpha symbol. I don't know why, but that is your z. Oh, this is your z. Now you see the alpha there. The alpha will present the probability. Alpha. Chapter 5, chapter 6. After this, we are going to use a lot this table. So you see, where is 0.1? Open your eyes big, scan the whole thing. 0.1 is where? Anyone saw it? Left hand side or right hand side or middle? Left. This one. Can anyone see this? 10% means 0.1, right? So what is the Z value? What is the Z value? 1.2816. I told you right, 4 decimal point. Even in exam, we use 2 decimal, it's okay. So 1.2816. Anyone cannot follow? Okay, let's say if I have 0.3, this one, no? 0.5244. If I have 0.05, 0.05 is 1.6449. This is a Z score value, or this is a Z up. Anybody tak faham? This is your alpha, is your probability. So 2.82816, sorry, 1.2816. So coming back to here, negative. Don't forget, you do put negative, because it's left hand side. Now we know how important is positive and negative. Even though the probability is the same, but it makes a big difference now. So you times one calculator times 100 plus 2000, 1744 hours. So any component electrical less than 1744, it will give you probability of 10%. Not easy to answer, right? That's why I say usually part A question student can get full mark. When come to part B, or macam-macam answer. So I hope you all can make it. Now, part B, if the mean lifetime increased to 20%, so what's the meaning mean lifetime? That's how 2000 is a mean life, right? Increased to 20%. Of the components will last for more than 2,200. Find the new mean lifetime. So you are finding what? The new mean life. So this 20% refer to what? Probability. To understand the question also take time really. Right? If you don't want to see the answer. So find the new mean lifetime. Last more than. More than means what? You have to use more than or less than the symbol. See, this is in English sentence, you must change the symbol. I told you, right, the first time you write wrongly, this no need to do already. So this one more than what? 2002. 20% is your probability. So how do you write? The question I need to find the new mean life one. So we don't know the mean life. We write as mean one, no? Mean one means the new mean life one. Okay? Because the old one is mean one. So we use mean one. No? So again, x more than 2002, 0.2. So we change this to what? So this one also minus mean one divided by 200. Standard deviation no change, right? Only the change is the mean one. So we minus the U1. That's the one we are looking for. Okay, 0.2. From the table, is this positive or negative? Let's say you tembak again, positive to here. More than means you shift here. Is it possible here 0.2? Yes, because this is a small area. If you tembak in the negative, it's correct, yeah, positive. But let's say those of you who first time speculate at the negative. What is given is outside, but this one is more than. So more than means you have to shift here. Do you think again this one can give you 0.2? Impossible, because this is already half, half something here, definitely more than 0.5, cannot be 0.2. So definitely this time you must take the positive side. Anyone don't get it? So now the next thing is, you must check the table again. What Z value give you 0.2? So go down to the table. 0.2 is there. 0.84. 6, there's a Z value. You see here? This is a Z, this is your alpha probability. So positive 0.8416. So you multiply 200 minus from 2002 plus multiply mathematics. So you get 2032 hours. This is the new mean lifetime. The old one is what, 2000, right? So the new one is 2032 hours, increased by 32 hours. So that those who have more than this hour, you will get 20% increase in the mean lifetime. Okay? So your tutorial question got asked the question, many one, don't worry, you're welcome to do it. Don't squeeze your brain until you get the answer. Do a good study. Okay, now this one also one example. You can try. Let's go through one more now. Yes. Which one? A. One Makey. What is your question? Mean the whole thing? Repeat again. Which one? I don't get your reply, so I'm not sure which one you want me to repeat. The whole A again or what? Or which part of part A? Okay, while waiting for a part B, whole of part B. Okay, maybe you all can try this one first. This one, right? Let me just go through it quickly. For the part B, make it. Later we come back again. The A questions. You mean this one, is it? Oh, this one. Oh, okay. This one, because of the only 10%, we fail. We fail means we have to put less than. Because less than that lifetime, we fail. If you have more than the Z value, then it won't fail one. So you have to, everyone have to be careful. Whether you use more than or less than, you have to read the question carefully. Okay, 10% means 0.1. So they give you the probability. You find back your Z value from the table. So this is your Z value, K minus 2000 divided by 200. Equalize it. Solve this mathematically. Okay, for part, this example, so you have 4 teller windows. Your customer is waiting and the mean is 3.8. Standard deviation is 1.5. So you let X is what? The time waiting for the customer. So X distributed as normal with the mean 3.8 and your standard deviation 1.5 squared. Okay, now here you have to find that the process ratio that customer irritated when the waiting time exceeds 5 minutes. Means that if the customer wait more than 5 minutes, the customer will get angry. So what proportion of customer will be irritated? Irritated means more than 5 minutes. You see, when you go to bank, you wait for more than 5 minutes, how do you feel? Angry, right? Not happy, because so lousy service. So what proportion means you have to find X more than 1 minute. So change the standard, because this is non-standard. And then part B, by adding a teller to the system. See, the bank have 4 teller, means what? 4 counter. You know, teller means counter. So the customer have to wait. Some take time, some very fast. So customer will be very angry if you have more than 5 minutes. So by adding a teller means what? The bank agreed to put extra cashier, you know, the counter extra, so become 5 already. the percentage, find the percentage of customer irritated will be, sorry, the percentage of customer will be irritated reduced to only 10%. So what's the mean waiting time for this extra teller? Assume the standard deviation won't change. Part A can get answer. Anyone will get A answer? All right. Part B. So now we have 5 cashier. The question line to find the mean for this new systems, which is the 5 teller. So we have to let mean as V1, new mean for the waiting time. When you reduce by 10%, so X more than or less than. And then the mean one is the one. So your question now is